Imagine a power plant the size of a small building that could produce enough electricity to power entire countries for thousands of years using nothing but seawater. No carbon emissions, no nuclear waste, no fuel shortages. Sounds like science fiction, right? Germany just proved it's possible. Deep inside a research facility in northeastern Germany, scientists have been building something that looks like it came straight out of a sci-fi movie. It's called Wendelstein 7X, and it might be the most important machine ever built. Here's what just happened. In May 2025, this reactor achieved something extraordinary. It sustained high-performance plasma with world record parameters for 43 seconds. That might not sound like much, but it beat every other fusion reactor on the planet, including designs that have been around for decades. This marks a major breakthrough. The data coming out of Wendelstein is rewriting the rulebook on fusion energy. And if the technology scales the way scientists expect, demonstration power plants could appear in the 2030 seconds, with commercial fusion becoming viable in the 2040 seconds. Welcome to the beginning of the fusion age. What makes fusion different? Let's start with what fusion actually is, because most people confuse it with the nuclear power we already have. Traditional nuclear plants use fission. They split uranium atoms apart, which releases energy but also creates radioactive waste that stays dangerous for thousands of years. It's powerful, but it comes with a massive cleanup bill and risks nobody wants to talk about. Fusion does the opposite. Instead of splitting atoms, it smashes them together. Specifically, it fuses hydrogen atoms, the most abundant element in the universe, into helium. This is the exact same process that powers the sunday. Think about that for a second. The sun has been burning for 4.6 billion years without refueling. It produces more energy every second than humanity has used in our entire existence. And it does it using hydrogen, which we can extract from ordinary seawater. Here's the mind-blowing part. 1 kilogram of fusion fuel produces the same amount of energy as 10 million kilograms of coal. Let that sink in. You could power a city for a year with fuel that fits in your backpack. The challenge nobody could solve. So, if fusion is this amazing, why aren't we already using it? Because recreating the sun on Earth is absurdly difficult. Inside the sun, hydrogen fuses because of extreme pressure and temperatures of 15 million degrees Celsius. Gravity holds everything together. On Earth, we don't have that luxury. We need to create temperatures even hotter than the sun, around 100 million degrees Celsius, and contain it without melting everything around it. Imagine trying to hold a piece of the sun in your hand without any container touching it. That's the engineering challenge. For decades, scientists tried different approaches. Most failed. Some worked for milliseconds before the plasma cooled down or became unstable. It was like trying to hold water in a basket made of fire. Until Germany built something different. Why Wendelstein 7X looks like alien technology? Wendelstein 7X doesn't look like any power plant you've ever seen. It's a massive, twisted ring covered in metallic coils that looks more like modern art than functional engineering. This design is called a stellarator, and it's one of the most complex machines ever built. Here's how it works. The reactor uses 50 superconducting magnets, each weighing 6 tons, arranged in a precise, twisting configuration. These magnets create a magnetic field so strong and so perfectly shaped that it traps plasma in midair. The plasma never touches the walls. It floats, suspended by invisible magnetic forces, while temperatures inside reach 100 million degrees. To put that in perspective, the plasma inside Wendelstein is 6 times hotter than the core of the sunday. The 43-second breakthrough. In May 2025, scientists at Wendelstein achieved something that stunned the fusion community. They sustained high-performance plasma for 43 seconds with record-breaking parameters. Now, 43 seconds may seem modest at first, but here's why the result matters. This plasma reached what scientists call the triple product, a measurement that combines density, temperature, and confinement time. Think of it as the key benchmark that shows whether a fusion reactor can truly operate as an energy-producing system. Wendelstein beat every competing design, including tokamaks, the more common fusion reactor type that have been setting records for decades. For long-duration, high-performance plasma, Germany just took the lead. But there's more. During testing phases, Wendelstein has achieved total plasma session durations of 6 to 8 minutes through pulsed heating, with energy turnover reaching 1.8 gigajoules. To put that in perspective, that's enough energy to power several homes for a day, not from burning anything, but from controlled fusion reactions. The German engineering miracle, building Wendelstein 7X, took 19 years and cost over €1 billion. Every magnet had to be manufactured with tolerances measured in millimeters. If even one coil was positioned incorrectly, the entire magnetic field would collapse. Think about that level of precision. These magnets aren't basic geometric pieces, they're twisted and curved in 3 dimensions, each one shaped by supercomputers to form an ideal magnetic cage. Straight lines and simple symmetry don't apply here. Every coil represents pure, optimized physics. One engineer described it as building a Formula One car, where every bolt has to be placed with surgical accuracy, except the car is the size of a building and operates at temperatures hotter than a star. They pulled it off. The path to commercial fusion. Here's where things get really exciting, and where we need to be realistic about timelines. Wendelstein 7X isn't designed to generate electricity. It's a research machine, built to prove that stellarators can confine plasma efficiently and stably, and it's succeeding beyond expectations. The data coming out of Wendelstein is already being used to design the next generation of fusion reactors machines, specifically built to produce power. Companies like Proxima Fusion are planning demonstration plants for the early 2030s, with the goal of building 1 gigawatt reactors at former fossil fuel sites. If those demonstrations work, commercial fusion plants could start coming online in the 2040s, not decades away anymore. Within the lifetime of anyone watching this video, energy density, like nothing else. Let's talk numbers for a second, because they're staggering. Fusion fuel is millions of times more energy dense than fossil fuels. A single glass of seawater contains enough hydrogen to produce the same energy as 300 liters of gasoline. Now, scale that up. The world's oceans contain enough hydrogen to power human civilization at current consumption levels for billions of years. We're not talking about centuries. We're talking about timescales longer than recorded human history. And here's the kicker. There's no geopolitical risk, no OPEC controlling supply, no nations are going to war over resources. Every country with access to seawater has access to unlimited fusion fuel. That changes everything about global power dynamics. What about the waste? Remember how fission creates radioactive waste that lasts thousands of years? Fusion produces helium. That's it. Helium is completely harmless. It's what fills birthday balloons. The reactor itself will become slightly radioactive over time from neutron exposure, but even that decays within decades, not millennia. Compare that to coal, which kills millions of people every year through air pollution, or natural gas, which dumps carbon into the atmosphere, or fission, which leaves behind waste nobody knows how to safely store for 10,000 years. Fusion is the cleanest energy source ever conceived, and Germany just proved the physics works. China, the US, and the fusion competition. Germany is not the only country pushing this frontier. China has been pouring billions into fusion research, building its own stellarator and multiple tokamak reactors. Chinese scientists have achieved plasma confinement lasting several minutes in their East reactor, proving that Asia is serious about leading the fusion revolution. The United States is backing private fusion companies like Commonwealth Fusion Systems and TAE Technologies, betting that startup speed can outpace government-funded research. Some of these companies claim they'll have demonstration reactors by the early 2030s. Then there's ITER, the massive international fusion project in France, which involves 35 countries and is designed to produce 10 times more energy than it consumes. It's the most expensive science experiment in history, over $20 billion and counting, but it won't be operational until 2035 at the earliest. Wendelstein 7X just gave the world proof that stellarators might be the best path forward. Why stellarators might win? Most fusion projects use a design called a tokamak, which is simpler to build but harder to run continuously. Tokamaks need constant injections of energy to keep the plasma stable, which limits how long they can operate. Stellarators like Wendelstein are different. Once the magnetic field is set up correctly, the plasma naturally stays stable. No constant adjustments, no energy pulses, just smooth, continuous operation. That's why scientists are betting Wendelstein's design could be the blueprint for the first commercial reactors. It's harder to build, but once it's running, it's easier to maintain. And maintenance matters when you're talking about power plants that need to run 24/7 for decades. The economics nobody expected. Here's something wild. Fusion might actually be cheaper than fossil fuels. Right now, the reactors are expensive because they're experimental. But engineers estimate that once fusion plants are mass-produced, the cost per kilowatt hour could drop below coal, gas, even solar. Why? Because the fuel is essentially free. You're not paying to mine uranium, drill for oil, or import natural gas. You're extracting hydrogen from water, which costs almost nothing. The only real expenses are building the reactor and maintaining it. And unlike solar or wind, fusion plants run 24/7, rain or shine, day or night. No batteries needed, no weather dependency. If the projections are right, fusion could become the cheapest energy source in human history. The reality check. So what needs to happen between now and commercial fusion becoming reality? First, Wendelstein needs to complete its research campaign. The next phase runs through December 2026, where scientists will push for even longer plasma durations, up to 75 seconds of quasi-steady, high-performance operation. Second, the data from Wendelstein will inform the next generation of reactors machines called Helios that are specifically designed to generate net power. These are the reactors that will actually feed electricity into grids. Third, demonstration plants need to prove the technology works at commercial scale. Multiple companies and governments are racing to build these in the 2030 seconds. If they succeed, the 2040 seconds could see the first wave of fusion power plants going live. A world transformed. Think about what happens if fusion works at scale. Climate change, the crisis that's dominated global politics for decades, suddenly has a solution, not a compromise, not a reduction in living standards, an actual technological fix that gives us unlimited clean energy. Developing nations get the same access to power as wealthy ones. Energy poverty disappears. Economic growth decouples from carbon emissions. Geopolitics shifts. Oil states lose leverage. Energy independence becomes real for every country. Wars fought over resources become obsolete. And space exploration? Fusion rockets could take us to Mars in weeks instead of months, to the outer solar system in years instead of decades. This reaches far beyond electricity. Fusion represents the key that could unlock the next stage of human civilization. Germany just proved that fusion power, real, stable, high-performance fusion, is no longer science fiction. The reactor that was supposed to be impossible just set world records. The plasma that couldn't be contained is holding steady at record parameters. The energy source that was always 30 years away is now on track for demonstration plants in the 2030 seconds and commercial deployment in the 2040 seconds. But here's the question nobody's asking yet. When fusion finally works at scale and energy becomes unlimited and nearly free, what happens to the countries that bet everything on oil and gas? Because the nations that master fusion first won't just lead the energy revolution, they'll control the future. Germany's fusion reactor shows where energy is headed. But engineering doesn't stop in the lab. Poland just launched a high-speed train, cutting straight through the mountains, linking Warsaw to Zakopane faster than ever. Click here to see how advanced engineering is reshaping Europe on the ground.